Welcome to this lecture on merchant circle. Here we will try to derive the force equations which are taking place during machining. So in merchant circle we have to begin with an assumption. What is this assumption? Here we assume that the chip that is coming out during machining, it is coming out at a uniform velocity or a constant velocity. So what it implies is that whenever a body is moving at a constant velocity, the forces which acts on the body are equal and opposite. So suppose here we will consider two forces from two directions. So this chip, as we have considered that it is coming out at a constant velocity, so the two forces that will be acting on the chip, one from the tool side and the other from the workpiece side, these two forces will balance each other. They will be equal in magnitude but in opposite direction. So to begin with, let us first see what are the forces that takes place from the tool side on the chip. Now the chip, while flowing out during machining, it will slide over the rake face of the tool. This surface is called the rake face of the rake surface of the tool. Now, so naturally, as the sliding action takes place, here a force of friction will be developed along this rake face, and one more force that will be developed, it will be in the perpendicular direction to the frictional force. This F is called the frictional force, and the normal to this F is called the normal force. And now if we draw a resultant here, R, this R is nothing but we have resolved this R into F and N. R is the total amount of force that is acting from the chip on the acting on the chip from the tool. Okay, now let us see what are the forces that are generated from the workpiece side to the chip. So the first component of the force is acting along the shear plane. This is called the shear force, Fs. This is our shear plane. This is our shear plane, and Fs acts along the shear plane. And naturally, one more component of the force, it is acting perpendicular to the shear plane. It will be named as Fn. And in the similar way, what we have done here, if we add these two forces, we will get a resultant R dash. This R dash is nothing but this is the resultant of, that is the total amount of force that is working that is acting from the workpiece to the chip, to our metal chip. Okay, now as I told earlier that this chip is flowing out at a constant velocity, so the force resultant force R and the resultant force R dash, this will be equal to each other, equal in magnitude. R is equal to minus R dash. Why minus? Because the directions are opposite. So now to derive the force equations, let us draw this vector here. This is my R, this is the R dash. What I have done here, I have simply drawn this R dash vector here. Now let me draw the vertical and the horizontal component of this vector. So if I draw the horizontal component, it will be nothing but it will give us the cutting force, the direction of the cutting force. And the vertical component, if I draw it like this, it will give me the thrust force acting on the tool. Okay, so up to here it is clear. Now I will try to compute, or I'll try to show the forces that are working on the chip from the workpiece side. Now just forget about this tool side. We will plot Fs and Fn here. How to do this? Now see, this Fs is the shear force that is acting on the R dash side. So from this point, I have to draw this Fs. Now see this shear plane, it makes an angle phi, which is called shear angle. It makes an angle phi with the horizontal. So our Fs force will be drawn like this. This is our Fs, and it is making an angle phi with the horizontal. Okay, so Fs is done. Now the next job is to compute Fn. What is Fn? Fn is a vector perpendicular on the Fs. So from here I can draw a vector perpendicular on the Fs. This is our Fn. Okay. Now see a very interesting thing. If we compare these two triangles, now we have this angle as 90 degree, this angle as 90 degree, this angle as phi. I want to know the value of this angle. How to do this? If we compare this triangle and this triangle, this triangle and this triangle, see this angle is same 90-90. These two angles will also be same because they are vertically opposite angles, right? Due to the vertically opposite angles, basic geometry, these two angles will be same. So in two triangles, if two angles are same, the third angle has to be same. The third angle of both the triangles has to be same. So this will become phi. Why it is becoming phi? Because in this triangle the third angle is phi. Okay. So up to here it is over. Now my job is to, now the workpiece side it is over. Now my job is to compute these forces F and N. Just look carefully. This frictional force F, it is actually taking place, it is working along the rake face, just along the rake face, and this frictional force F, it makes an angle, this angle with a vertical line. So now if I plot a vertical line, then along with this vertical line, if it is making an angle alpha, and if I draw a line, it will give the value of F. Okay, just I am correlating with this figure. This is my parent figure, main figure, and correlating it with this one. Okay, so now I have plotted F. The next job is to plot this normal force N. Normal force is nothing but a force which is perpendicular on this on this vector F. So here we get our N. Now if I join this all these points, now our main step will is to get these angles, get the value of these angles. What are the value of these angles? So let us see how to find out this. This angle is 90 degree, right? It is perpendicular. This is alpha. So what will be this angle? Obviously 90 minus alpha, because sum total of all the three angles is 180 degree. So if one is 90, this is alpha, this is maybe 40 degree, so the other is 90 minus 40 is equal to 50. So these are all coming from basic geometry. Okay, so now this is 90, this is 90 minus alpha. This angle again, it is 90 degree, it is perpendicular. So what is this? It becomes alpha, because if you add it, you will get 180 degrees. Now what is my job? My job is to derive ft, equations of ft and fc in terms of fs and fn. So what is ft? This length ft is nothing but ob, this entire length, this full length, ob minus ab, this full length minus ab, if you take, you will get ft, isn't it? And what is fc? Fc is nothing but, fc means this full length. Fc can be again written as this length plus this small length. Okay, so this is how we will get fc and ft in terms of fn and fs. Okay, so now let us try to derive the equations of fc and ft. So first, if we consider fc, that is the cutting force, it can be written from this diagram as this as. Fc is the total length. Then the fc can also be written as as plus sr dash, as plus sr dash. Now this value sas, this is exactly of the same length as bq. Since abqs, it is a rectangle, so this side as and bq are equal. So indirectly we have to find out. So what is bq? Bq means, if we consider obq, this is a right angle triangle, so this bq will be equal to fn. This is the fn, this is the hypotenuse of this triangle, fn sine phi. plus SR dash. How to find this SR dash? If we consider this QSR dash, QS is the perpendicular and QR dash is the hypotenuse. So SR dash is nothing but Fs is the hypotenuse cos alpha, cos phi. I have not done anything special. Just I'm applying the simple basic trigonometric relations here. Okay. Okay. So now this is our equation 1, and to find out the thrust force Ft, Ft is nothing but OB minus AB. This is the length Ft. It is not. It can be written as OB minus AB. OB minus AB. So what is OB? OB, if we consider OBQ, OB is the perpendicular. So from this triangle, it can be written as OB is equal to Fn is the hypotenuse. Fn, Fn, it will be cos phi. Cos phi minus what is AB? What is AB? AB can be written as QS, because as I told you, this is a rectangle, so this length AB and the perpendicular QS is same. So from triangle right angle triangle QSR dash, AB can be written as in terms of QS as Fs sine phi. So this is our we have got these two equations. So now what is our aim? We have to now find out Fn and Fs in terms of Fc and Ft. Okay, our aim is to now find out this shear force Fs and perpendicular to the shear force Fn in terms of Fc and Ft. So what we can do to find out this? Just look at these two equations. When we want to find out Fn, then we can multiply this equation in with sine phi into equation 1, and then again this equation we will multiply with cos phi. Why? Because in this equation cos phi is present along with Fn. So in the first equation, sine phi is present with Fn. In this second equation, cos phi is present with Fn. So this equation into sine phi plus this equation into sine phi. So if we do this, let us see what happens. Equation 1 into sine phi plus equation 2 into cos phi. This is the second equation and this is the first equation. Okay, so if we do this, what we will get? Fc sine phi is equal to Fn sine square phi plus Fc cos phi sine phi. And now equation 2, this equation into cos phi, if we do, then we will get Ft cos phi is equal to Fn cos square phi minus Fs sine phi cos phi. Okay, so now if finally we have to add these two equations. We have to add them, these two equations. If we add, finally we will get the value of Fn. You can try it as Fc sine phi plus Ft cos phi. This is what we will get, the value of Fn. Similarly, to get the value of similarly to get the value of Fs, we can try the same thing. To get the value of Fs, I'll show you one trick what we can do. See, in this equation, along with Fs, we have cos phi. and in the second equation along with fs we have sine phi. So in this case, to 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 find out fs, I have to multiply equation 1 with cos phi. Earlier we multiplied with sin phi to determine fn, but to determine fs we have to just do the opposite thing. Then if we subtract this equation, this equation with the second equation into sin phi, we can easily derive the equation of fs. Fs will come out, you can derive and check it. If fs will come out something like fc cos phi minus ft sin phi. So this is another relation. So these are the two relations of fn and fs. Now what are these fn and fs? These are the forces that are going onto the chip from the workpiece side. So we have derived their relation. Now in the next step we have to repeat this entire process for f and n for the tool side. So now we will find out the values of f and n in terms of fc and ft. So how to do this? This is very simple. Here we can write this ft as, ft can be written as this length plus this length. Let me name it as l m n. Okay, so ft can be written as ol sorry al minus ol. So what is this value of al? This entire length al can be written as r dash n. This length, this and this are equal. Okay, and minus this ol, what we can write, we will keep it as ol. And then if we take this triangle r dash n m, from this triangle we can find out the value of this r dash n can be written as f is the hypotenuse cos alpha minus ol. Now ol we have to find out from olm, this triangle. So from this triangle we can, by using this trigonometric relations, we know we can write it as n is the hypotenuse sine alpha. So this is our ft. This equation can be written as third equation 3. Now fc, how we can write this fc? Fc can be written as, this entire length can be written as lm plus mn is equal to lm plus mn. What is this lm? Lm is nothing but n is the hypotenuse, n cos alpha, plus what is mn? Mn we can find out from this triangle m r dash n. From here we can write mn as f is the hypotenuse sine alpha. So this is how we have got ft and fc in terms of f and n. Now like previous equations, what we have to do, we have to find out the values of f and n in terms of ft and fc. Okay, inverse thing we have to do. So for this, as I told you earlier, we will apply the same trick here. Let us write both these equations here. fc, will first write the equation of fc, n cos alpha plus f sine alpha. We are naming it as the third equation. Okay, and ft is equal to f cos alpha plus ft is minus n sine alpha. So we will assume that this is our fourth equation. So now to find out F, let us first find out F. So how to do this? See, to find out F, first we have to check in that in the third equation what is lying along with F. It is sine alpha, and in the fourth equation along with F, here we have cos alpha. So what we can do is that if we multiply the third equation into sine alpha, because we are trying to find out F, so whatever is lying with F, we will try to multiply it, and then if we add it with the fourth equation into uh, cos alpha. Why cos alpha? Because in the fourth equation along with F we have cos here. So if we do it, we will get our F as something like FC sine alpha plus FT cos alpha. Okay, so this is the equation of F, and now we have to find out the equation of N. Now to find out the equation of N, it is very easy. What we have to do is that in the third equation, what is lying with N? It is cos alpha. So equation 3 into cos alpha, then it will be minus here, because here it is minus is there, minus equation 4 into sine alpha, because in the fourth equation sine alpha is lying with N. So if we do this, we will get the if you didn't do all these steps, you will get the value of N as FC cos alpha minus FT sine alpha. So this is our final equation of N. Now if you need to find out the value of mu, I am writing it here. Mu is equal to F by N, coefficient of friction. So directly you can replace F with this equation and N with this equation. So this was all about Merchant circle. Now we will see. Now we will try to summarize all these equations, deriving all these equations. These four equations are of primary importance. This is the Fn is the normal to the shear force in the workpiece side, and Fs is the force that takes place along the shear force. These two forces are from the workpiece side, to the chip, and these two forces are from the tool side. This takes place in the tool. What are these? This is the frictional force that acts along the rake face, and N is the normal to the frictional force. If any doubts, please feel free to ask in the comment section. Thank you.